Hello everyone, welcome to my channel Middleware Technologies. Today we'll be looking at how we can authenticate a Kubernetes API request using the client certificates. Okay. So Kubernetes is a very popular open source orchestration engine tool. It is widely used in organizations to manage their workloads. Basically they help in launching the containerized applications or microservices application and manage them with scaling, deployment and failover facilities which are provided by orchestration engine. So that is the purpose of Kubernetes. Here in this video we will be looking at how we can authenticate an API request to the Kubernetes cluster. There are various methods which are supported by Kubernetes for authentication, like client certificates, passwords, static tokens, bootstrap token, JWT token are some of them. Okay, so we'll be using the client certificates over here. We'll be generating the client certificates and we will try to configure the kubectl so that we can authenticate that user with the client certificates to the Kubernetes cluster. Okay, and in Kubernetes, there are only on a high level there are only two types of users or identities that access the resources. One is the external users, that is human users or normal users you can see, and the other one is the service accounts. Service accounts are generated internally or we can generate it manually. They are used within the containers which will be used to access the resources within the cluster. Okay, so let us see how we can use the client certificates to authenticate a Kubernetes API request. So this is a document that I am going to refer for this activity. So as a first step we need to generate the private key for the client or the user. Okay, so let me use this OpenSSL command line utility to generate the private key. So I am now in a empty directory like lab which I'll be using to do this activity. Okay, so let us generate our private key. Let us name it as dev user 1 and we'll be generating a key of length 2048. Okay, now our private key is generated. The next step is we need to generate a certificates signing request from this private key. So for that we will be using OpenSSL request command line utility and pass the CSR, pass the private key. Okay, so here we are going to pass the private key and generate a CSR in dev user 1 CSR. Okay, so here we need to provide the details of our certificate. So I'll name the country as India, state MH, locality Mumbai, organization let us name stack, unit we can name it anything. The CA name, I'm using the CA name as a host name of my master server. The other details you can leave it empty. Challenge password not required, optional company name not required. So these details you can just update accordingly for your certificate or your organization needs. Okay, so here we have generated the CSR for the private key. Okay, now what we need to do is we need to send the CSR to the Kubernetes cluster to get it signed. Okay, so for that we need to first convert our CSR into base64 encoded format. Okay, so we'll be converting our CSR into base64 encoded format. Okay, so my CSR name is dev user 1. Okay, so this is the base64 encoded CSR which we need to send it to the certificate Kubernetes cluster for signing. Okay, so let me copy this content. So we need to generate a certificate signing request YAML definition file which will be going to apply in the cluster which actually generates a CSR request for the API server to sign it. Okay, so let me create this CSR signing request. Let us name this as dev user 1. Okay, so let me save this one and apply the CSR. So now we have created our CSR. So if you go and list the CSR, it will be in the pending state. Okay, so we have the dev user 1 CSR which is currently pending, which needs to be approved by the Kubernetes signing authority, the certificate authority, so that we can get the new certificate. Okay, so now we need to approve the CSR. Okay, so here like we will be using Kubernetes certificate approve to approve our CSR dev user 1. Okay, now the CSR is approved. So if you go and see the CSR again, now it is in approved state. Okay, so let us get the certificate from the CSR. So if you go into get CSR and output it in the YAML format, you will get this certificate. Okay, but this is base64 encoded which we need to decode. Okay, so for that we are going to again use the base64 utility to decode it. So first we will use, let me copy this command. So here what we are doing is we are just generating the dev user 1 CSR, like returning the dev user 1 CSR, and from that JSON we are going to extract the status certificate content and decode it using the base64 and save it into the .crt file. Okay, so let us name our CRT file as dev user 1 CRT. Okay, so here this has generated our CRT file. Okay, so this is our certificate. So if you go and check this certificate, let me show you. OpenSSL X509, that is certificate, input dev user 1 CRT and text. So let us output is as text. Okay, so if you go and check this certificate, the CNAME of our certificate is this one, CN is equal to QMaster, and all the details which we have provided, and the certificate signer, like as you can see, the CA name is Kubernetes. So this is the CA authority certificate of the Kubernetes cluster which has signed our certificate and which is valid for 1 which is valid for this duration. Okay. So this is our certificate which we have like generated. Now what we need to do is we need to create a rule that is a set of permissions which we want to provide to a particular which is a set of permissions. Okay, so let me generate this rule. Okay, so let me name this role as developer1. Okay, and this role actually gives access to pods, like we can carry out all these activities with the pods. Okay, so let me save this and apply this role. Okay, so if you see get role developer1 output YAML, so you can see the role has been applied. Okay, now let us do a role binding. That is, we are going to map this role to the dev user one which we have created earlier. Role binding name is developer1. Let's see, dev user one bind to dev user one. Role name is developer1, username is dev user1. Okay, so we have applied the role to that user. Okay, so if you go and see get role binding, output YAML, like you will see the user dev user1 is mapped to this role developer1. So now we are good, like we have a role which is mapped to the dev user1. The next step that we need to do is we need to configure our kubectl configuration file by setting those credentials or the client certificates which we have generated. Okay, so for that we will be using kubectl config set credentials. So let me take this command. So we are using kubectl config set credentials, name dev user1, and the client key which we have generated is dev user1 key, client certificate is dev user1 cert, and embed cert is equal to true, so that we are going to embed that certificate into the configuration. Okay, so the dev user1 credentials has been set. If you check the kubectl config view, you will see a user named dev user1, so this one dev user1 with client certificate and client key applied into the configuration. Okay, now we have created our credentials, or like we have created our user. Now we need to create a new context. Okay, so for that we will use the kubectl config set context. So context is basically like mapping the user to a cluster. Okay, so we will be naming our context as dev user1. We will map the cluster like which is currently available. So this is default cluster which we get using the kubeadm deployment or like provisioning of the cluster, and this is a user which is generated. Okay, so let us apply this context. So we have created a new context. So let me do config view again. So if you go and see, okay, let me go up a bit. You can see in the clusters, like we have the Kubernetes cluster, this one, and in the context, like we have just generated this part. Okay, the context is named devuser1, which maps the cluster Kubernetes, which is this cluster, with user devuser1. So basically we are providing access to this user in the following cluster. Okay, but this user devuser1 is given a set of permissions using the rule binding which we have applied earlier in the previous steps. Okay, now we have our context ready, that is dev user1, but let us see which context we are currently in. Get context. So you can see, like currently I am on Kubernetes admin at Kubernetes, which is the admin cluster. Okay, but I need to switch to dev user1 context. So before that, let us try to get Kubernetes ADM has a full access to the cluster, so we can restore the resources, so there won't be any issues here. So let us map to a different the context which we have created, kubectl config use context dev user1. So now we have switched the context to dev user1. So you can see we have switched to dev user1. Now we can try to list the kubectl get pods over here. Okay, so looks like we have generated our certificate with cname kubemaster, which actually supposed to be dev user1. Okay, let me try to correct it quickly. So we will generate a let us generate a new private key, dev user2, and generate the CSR again. Astra Mumbai stack organization unit DevOps. Common name here we will be using dev user2. Email challenge will empty, optional company empty. Okay, so we have generated our CSR now. So let us convert the CSR into base64 format. Okay, so CSR name is dev user2. Okay, now generate our certificate send request again. So now we have our CSR definition ready. So let us apply this one. Okay, so dev user2 is the CSR which we want to give the certificate to. Okay, kubectl apply this new CSR. correct the name. Okay, so right now I am in the context of dev user 2. So I'll have to change my context. Okay, kubectl config use context. Okay, so change it right now, and let us try to apply our CSR. Okay, and let us try to check the CSR status now. It is in pending status. So kubectl it is approved the certificate now. kubectl approved dev user 2. Okay, now the CSR is approved. We can get the certificate. So let us generate our certificate dev user 2. CSR is dev user 2. Okay, so we have our certificate now ready for dev user 2. Okay, so now let us apply. So role is already present. We need to bind that role to a new user. So let me bind that again to user 2. Role is the same, and let us name dev user 2 developer role binding. Okay, create role binding. Okay, so this is going to create our role binding, and now let us apply the credentials. So we'll set the credentials for the new user, that is dev user 2. So we need to name test dev user 2 certificate, dev user 2 key, set credentials for dev user 2. Okay, user dev user 2 has been set. Now let us set the context for this new user. It is mapping the cluster to the user. Okay, so the new context is created. Let us try to test it now. So we will use that context now, dev user 2. So if you check kubectl init context, we have mapped to dev user 2 now. So let us check list the pods. We have pods. Okay, so you can see there is a pod running right now, but if you list and get namespaces, you will get a forbidden error because the dev user 2 has not been given the access to the namespaces like as per the rule which we have applied. So yeah, so this is what I wanted to show you in this video, like how we can apply the client certificates for new user and authenticate an API request in the Kubernetes cluster. Okay, I hope you learned something new in this video. Thank you all. Thanks for watching this video, and you guys have a great day.